Hi guys, welcome to my channel. In our world, today I'm gonna discuss a topic about a concept of heat and work transfer. In this topic, I will tell you the tricks to remember the heat and work transfer sign convection. So first comes to the heat transfer. So what is mean by heat? Heat is a resultant of pressure difference, is a mode of transfer of energy. um, if you know, the heat always move from higher to lower. Not only heat, pressure, temperature, anything, it's move always from the higher to lower level to maintain an equilibrium. Now already in my previous video I have explained what is meant by system, boundary and surroundings. So what happens, this q denotes a heat. Okay, so when heat is added into a system, that is being considered as a positive sign, and when the heat is liberating from the system, we consider as a negative. And you should remember this sign convection. In my later part of my video, I will tell you how you can memorize it. So first you focus on this. When the heat is added, we give a positive. When heat is liberating or coming out from the system, is negative. So also remember this last 2 point, that is a heat transfer depends on a path function and heat is not a property of a system. Next comes work. So you know the definition of a work in mechanics. It's a displacement against a resisting force. Both the work and the heat having a same unit. So how you can define a work? Just imagine a piston engine. Piston engine, what it does? The piston moves to and fro, making a displacement. So when there is a point of displacement into the system, so that gives a work. And when this kind of system making a work and generate a power, that is causing a heat. So like how this both heat and work are interrelated. Now you see here, it's a very different thing. When the work is getting into the system, we say that is a work is negative. But when the work is done by the system, we called as a positive. So here you might get big confusion right now, so keep it, hold it with you. I will come to that point next. You remember this work transfer, that is depends on a path function for exact differential form. This is very important point. And work transfer is also not a property of a system. Both the heat transfer and the work transfer is not the property of a system. Both are the path function for the inexact differential form. Both the heat and the work transfer is a path function. They are not the property of a system. You better remember that. What is meant by property? We have already studied the property. They are not the property. They are only the path function. Yeah, here comes the sign convection. So you can see that I have written q plus, q negative, w negative, w plus. So what is meant by w plus means when heat is added by the system or into the system or to the system. Did you got it? So q means what? Heat. W means what? Work. So when we get plus, you remember this diagram. Okay, so first we have plus, then negative. First we have plus, then negative, then negative, then positive. You remember this, just like how you take a photography. Just take the photography in your memory. So first what you do, the system, both have the system. Now here you have a q plus. Here you have, first you're doing a heat, then you're studying a work. So here both the cross we have a same sign. Okay, both the cross side we have a same sign. So what is the matter? When we are here, we are entering, this is out, this is entering, this is out. So when you are entering a heat, it becomes positive. When you're leaving the heat, or heat is liberating from the system, we get as a negative. Okay, see, also have, for your better understanding, I have negative means a red mark. Okay, so both the negative I have boxed it out with a red mark, and the positive value I have blocked it out with my black color. So when and what happens, and when the work is done by the system, we give as a negative, or into the system negative, or we can say work is of out of the system is positive, or from the system, or work done from the system, we always say this positive. You better remember this word, or in other words, like when for your better understanding, you can either say, remember like this: by to q is positive, or from work is positive. You can, in a question paper, if you see or other terms for that, you can simply keep negative. So if in a question, if you see like a heat is liberating, or heat is coming out from the system, or heat is coming out from the system, yeah, you have to mark it as that heat value as negative. If you see work done into the system or by the system, you have to note that work done is a negative. Or rather, you can see from the system, or the work done from the system, it has to be a positive. Okay, so remember one thing, another tricks I have made it for you, that is heat input. When the heat is getting into the system, see the arrowhead, you see the arrowhead, that is better, you see the arrowhead. Okay, so when into the system is always positive, and when the work output, the output you're getting, okay, what's the output? This is output, right? You're getting output is always positive. This is either of the way you can remember. I hope this will be useful. At least you will be having a clear concept about this sign convection by right now. So I will give a little discussion about a first law of thermodynamics. So already everybody know what is mean by first law of thermodynamics. It's a principle of conservation of energy. What is that? Heat energy can neither be created nor be destroyed, and it can be changes converted one form to another form. So this form, and this formula is very important, that is q equals to del u by w. So what is meant by q? Q is a heat energy and w is a work done. So this heat energy and work done are not equal. Okay, what is amount of heat energy you're giving, inputting into the system, the output you're getting some, the output you're getting less, actually the work done is coming less. So what is a del u? Del u is an internal energy. Okay, some amount of heat is absorbed by the some internal molecules, that is called internal energy. So when you want to get a equivalent amount of heat energy, that becomes equals to the summation of internal energy plus work done. So here I have given some of the few problems which is usually discussed in competitive examination. So let's see one question. Click process, heat transfer are plus 14.7 kilojoule, minus 25.2 kilojoule, minus 3.56 kilojoule, and plus 31.5 kilojoule. Then the net work for the cyclic process. They have given a heat transfer, that is q value they has been given, around 4 q values they have given, and they're asking a work done. So let's focus the solution. First, when they give the negative sign, you better see the diagram. See what they have done is, like here first, when it is positive, your symbol will be like that. When it is negative, your symbol is going outside. Okay, it's outside, inside. So now what you do is, you know the summation of heat transfer. Okay, summation, you just sum it up all the values, that is q1, q2, q3, q4, you sum it up and you get a 17.44 kilojoule. Now what they have asked, this is an cyclic process. So we know the cyclic process, you focus on that from first law of thermodynamics. For cyclic process, okay, summation of heat transfer is equivalent to the summation of work done or a work transfer. So since this is a method, and therefore we get work done as 17.44 kilojoule, same value. That's the answer. It's very simple, I hope. It is very easy. Next come the next question. During one cycle, the working fluid in an engine engages in two work interactions. Okay, there is one cycle. In one cycle, two work done is taking place. One is a 15 kilojoule to the fluid and one is a 44 kilojoule from the fluid. I said you to the fluid and from the fluid. You better remember. So what is meant by from the fluid is positive and to the fluid become negative. Okay, and three heat interactions, two of which are known. So among the three interactions, that is heat transfer, two have been given, that is 75 to the fluid and 45 from the fluid. So evaluate the magnitude and direction of the third heat transfer. So in this process they have given not given the third one, so we have to find the third one. Let's go to the solution. You see here is a diagram. This q1, q2, q3. Q3 is not given, so when they're asking from the heat transfer from the system or a fluid, we gave as negative, and work done into to the system we give as a negative. So you better focus on the sign convection I have said you. Let's see the solution. From first law of thermodynamics, for a cyclic process, you know that is summation of Q equals to summation of work done. Now I have written like that, Q1 plus Q2 plus Q3 equals to W1 plus W2. Now I'm going to substitute those values in this formula, and from there I have calculated Q3 equals to minus 6 kilojoule. Okay, so our answer is minus 6. We have to mention minus 6 because they have particularly mentioned that to mention the direction. Okay, that's all. So I hope these two questions will be useful for you to understand the concept of heat and work transfer. So thank you for watching this video. I hope this was useful for you, and if you have further inquiry you can drop me mail by 948922411 ash@gmail.com. Thank you, bye, have a nice day.